All right, in this video, we are going to talk about the following problem. It says write a recursive method that computes and returns n factorial. So n factorial, right, if n is greater than or equal to 0, then is the product of the first n positive integers, okay? And then 0 factorial is 1 by definition in math. And it's just really more of a convenience than anything else. It's way more convenient to define this as 1 instead of 0 because it makes a lot of formulas a lot nicer than if you define it to be 0. So it just makes more sense to do this. All right, and 1 factorial would be 1, 2 factorial would be 2, and 3 factorial, and so on and so forth. All right, so we need to write a recursive method to do that. And the key observation, right, on this, if you want to write it in recursive format, is this, right? If I look at these and not multiplied out, but if I kind of write them in the expanded format, right? 2 factorial is 2 times 1, right? And 3 factorial is 3 times 2 times 1, right? You can see that this part here, right, appears right here. So 3 factorial, right, appears in, or 2 factorial appears as part of 3 factorial. And then if I do 4 factorial, right, by definition, that's 4 times 3 times 2 times 1. You can see that is just 3 factorial right there. And then 5 factorial, right, is 5 times 4 times 3 times 2 times 1. Now you can see that is 4 factorial right in here. So when you want to compute the factorial of some number, say like 5 factorial, right, all you really need to do is figure out what 4 factorial is, right, the one that came before it, and then multiply that answer by 5. Okay, so that really is kind of the key observation here as to how to write this in a recursive manner. Okay, all right, so here is our method, and we're going to add another method in here, public static. The return type, these factorials, right, are ints, right? So it's going to return an int, and I'm just going to call the method factorial. And it should have an int parameter in here. I need to know what number factorial I'm trying to compute right here. Okay, so I usually like to think of what is the base case first, right? And in this case, the base case is going to be that 0 factorial is 1, okay? So what I would do here is usually have an if statement, right, for the base case. So if x is equal to 0, then return 0, not 0, but 1, right? Because 0 factorial is 1, okay? And let's just test that out. Actually, it's not going to compile, right? It's going to give us an error because it says missing return statement, right? So the reason why it says missing return statement, even though we have a return statement is here, is that this condition could easily be false, right? Whatever comes in for x might be not 0, and so therefore this would be false, right? So just as a placeholder for right now, let's just put return 1, okay? So then that will keep Java satisfied. It will compile, and we can test our program a little bit. And I'm just going to put system.out.println, and then a call to the method factorial 0. Just test that out. All right, so we should get 1 when we run this, right? Actually, we're guaranteed to get 1, so let's just to make sure that that's working right, we'll change this to 2. All right, so 0 factorial is 1, right? And so that's good. That's working fine. But obviously, right, if we change this to 4, we should get 24, right? And we're not going to get 24. Okay, because all we have is the base case itself, all right? So now what we need is the recursive call itself. We know, right, if this thing is going to be a recursive method, it has to call itself, right? And so I'm going to add an else clause for what to do if x is not 0, okay? And I'm going to move this return statement inside here. Okay, and so now the question is, well, what are we going to return if x, we're obviously 2 is not correct, right? So we're going to take that out. What are we going to return if x is something that's other than 0, okay? Well, and again, the key observation here is that if I want to compute 5 factorial, right, then all I've got to do is compute 4 factorial, the one that came before it, right? And then times that by 5. Or if I want to compute 4 factorial, I would just compute 3 factorial and then multiply by 4. Or if I want to compute 3 factorial, I would compute 2 factorial and multiply it by 3, right? So calculate the one that came before it and then just multiply by whatever factorial that you are trying to compute. So we're trying to compute x factorial, so we would take and say x times, and then now here we would call the method itself, right? Factorial method again. So there's where our call to the function, our recursive call is going to be, right? And so here, right, what we want to do is not call it with x, but x minus 1, all right? So in this case, what will happen is that that this part will compute the factorial of the number that came before x, right? And then it will pass this, and then we'll just multiply it by whatever value x is. All right, so let's test that out with factorial 4 and see if we get 24. And we do, right? And 5 should be 120. 6 should be 720, I think. Yep. So 3 should be 6. All right, so it looks pretty good. And again, on these, right, to me, trying to understand this, you have to kind of trace through it and see how it's working, okay? So let's do a trace through this really quickly, just so you can better understand how this is working. Okay, so we're going to do factorial 3. All right, and factorial 3 was if x is equal to 0, which is not, right? So it skipped that part, and we went into the else part, right? And in the else part, it was return 3 times factorial 3. Okay. So that's what we would have, 3, oops, sorry, not factorial 3, but factorial 2. By the way, that would get stuck in an endless loop, so you might have to hit end. Okay, so 3 factorial 2. All right, so now Java sees this method call right in here in the return statement, and so it calls the method again, right? So it calls factorial 2. All right, and then the code, it runs through there. If x is equal to 0, it's not, right? So it goes to the else part. And in the else part, it does return 2 times factorial 1. All right, so this 2 came in here. All right. Then it gets called again, right? In this part, I have the method call again. So here I have factorial 1. That 1 coming from right here. All right, then inside there, inside the method call, when we call factorial 1, right, we get if x is equal to 0, x being 1, right? I guess I should write that as a 1. It's not, right? So that would jump into the else. And there we do return 1 times factorial 1. All right, then factorial 1. Sorry, 0. Keep messing it up. All right, so then factorial 0 gets called. All right, that 0 coming from here. All right, and then in there we have if 2, man. If 0 equals 0, which is true, right? In this case, then we return 1, right? That was what's going to happen, right? You can see here, right, in our code, we return 1 right here. All right, so now what that means is that this 1 here now gets returned. So it gets sent back here. And now we have 1 times 1 right here, which is 2. No, it's not 2, it's 1. Jeez. Okay, it's 1. All right, so next up, right, that 1 gets returned back up here. So up here we have 2 times 1, and that is 2, right? And so that 2, right, now gets returned back over here. And so now we have 3 times 2, which is 6, right? And that is going to be the answer, right, that is returned on this call, okay? So you can see what you get is sort of a chain of these method calls, right? Each time, right, the method call, the thing that you're calling, gets dropped by 1 each time. 3, 2, 1, 0, until finally it hits the base case. So it's basically you're kind of going down this chain of methods, right? Until you bottom out, right? And it's going to bottom out on the base case, right? And the base case is, that's going to end the recursion, right? There's no more, the method's not calling itself anymore on the base case, right? And so that's going to return this number 1 in this case, and then that's going to pass it, you know, from the bottom, and that's going to be start to get data and values passed upwards. So this 1 is passed up here. It makes its calculation, right? And passes that calculation up, right, to the next function call. So now these function calls are completed. So now this function call or method call has what it needs, right, to compute its return value. So it computes that and then passes it back up the chain of method calls all the way till we get all the way back to the top, right? And then the top call there finally completes everything and prints out the final answer. Okay. So to me, you really have to think about it in terms of this and write it out and really examine it. It's not the easiest concept to get a hold of, but if you write it all out like this, it's much easier than if you don't. If you don't take the time to write it out and try and think about it in these terms, it makes it really hard to learn. So highly recommend that you do that. And now, not like I mentioned earlier, not every problem is going to be easily solvable by recursion, right? But this one definitely is, right? This factorial computing that just kind of lends itself to that, because what we've seen is that it's pretty, if you know what the factorial before the one that you're trying to compute is, it's really simple, right? So if I know that 4 factorial is 24, then all I really got to do is to calculate 5 factorial is multiply 5 times 24, right? And so that made it makes this set up really, really nicely for recursion, right? The solution to any stage of this is an easy calculation if you know the previous stage. Okay. All right, that is it on this one.